Hey there, I am Joe by name, and this is Nursing Tutorials with Joe. Today we are going to be looking at electrocardiogram reading, the normal reading. You must have seen an ECG chart before, and you might have wondered, what are these lines about? What do they represent? That's why I'm here today, to tell you about it, give you the normal interpretation of the ECG reading. First of all, ECG means electrocardiogram. This is a non-invasive procedure that reflects or reveals the heart rhythm or the heart pattern. Now, it measures and records the electrical activities that goes on in our hearts. It does this measurement at a rate of 25 millimeter per second. Now, the ECG chart is composed of a horizontal and vertical lines, which makes them up. Now, another thing we must understand is that the ECG is used for checking the heart condition, especially the electrical activity of the heart, if it is normal or abnormal. Then also, we can use it in diagnosis to find out if there is a dysrhythmia or an arrhythmia, maybe there is a fibrillation or a flutter, and others. Then we can also use it to assess the extent at which the medications are working. These are the uses of the ECG. Now, one basic thing we must understand in reading the ECG is that the ECG chart is made up of waves, as we can see. Now, just like the sea, remember in our sea bodies we have waves, waves of water that comes up once in a while and falls back. They come up and falls back. That's the same thing that just reflects here. So we have some waves that go up and come down, while there are some maybe that go down, that normal, and come up. All of them are classified as waves. Now, for normal ECG reading, we have 5 major waves. We have the P wave, we have the Q wave, the R wave, the S wave, and the T wave. The PQRST is a particular part of the English alphabet. That's where they are gotten from. Now, let's look at how we can locate each of the waves and what they represent. The P wave occurs at this point and represents atrial depolarization. By depolarization, we mean influx of calcium channels into the cardiac muscle, and that leads to contraction. Remember in that the atrium contracts, and its contractions leads to pulling of blood down into the ventricles. For more details on that, you can check our tutorial on blood flow through the heart. Alright, so this is the P wave that represents atrial contraction. From there it moves on the normal line, and there is a downward deflection which forms the Q wave. The Q wave is the first negative wave. Why? Because it's going down beyond normal, and it represents what? Interventricular depolarization. So it is the beginning of ventricular contraction. Now, from the Q wave, there is an extension. The Q wave ends at this point. You can look at it as a wave. The P wave like this, the Q wave like this, and from here you have the R wave, which goes up and comes down and stops at this normal point. This represents what? Ventricular depolarization. So this is now the height of the ventricles contracting. After the R wave, you still have another downward wave, the second negative wave, as the S wave. You can see it is a wave. It goes down and comes up a bit. Now, the S wave represents the depolarization of the Purkinje fibers. After the ventricles have contracted, the Purkinje fibers also contract. Now, the QRS waves form what is called the QRS complex. And all of them represent holistically ventricular contraction, or we say depolarization. Alright. Now after the S wave we have another wave here, T wave, which represents ventricular repolarization. We can also liken it to ventricular relaxation. So after the ventricles contract, there is a relaxation, and that's what the T wave represents. And after that, it continues as a P wave, and it just continues like that. Now, there's another extra wave, U wave, that is not supposed to be. It represents Purkinje fibers repolarization. It's not supposed to be there, but it only appears in certain disease conditions like myocardial infarction and any other cardiac ischemic diseases. So it's not supposed to be there, but when it is prominent, then it's an indication that there is a myocardial problem. So this is it about the PQRST. Now next we look at intervals and segments. Okay, now we are going to be looking at intervals and segments. Now, as a way of continuation, we have some intervals here, and we have just one segment we'll be looking at. What are the intervals and what are these segments? They are different points, combination of maybe one or two waves together. Alright, the PR interval signifies the beginning of atrial depolarization till the beginning of the QRS complex. So we call that the PR. Now, what's the significance of this PR? An increase in PR shows that there is bradycardia, that is low or reduced the number of heartbeats or heart rates. While when it is shorter than normal, it shows that there is tachycardia, that is fast heart rate. Alright, the next one is the ST segment. This is, it signifies, it starts from this point, at the end, at the beginning of the ST segment. Okay, the ST segment begins from the end of the S wave and ends at the beginning of the T wave, and that is why it's called ST segment. Now, why is it very vital? For example, in myocardial infarction, there are two types. There is ST elevation myocardial infarction, and there is non-ST elevation myocardial infarction. So meaning that when this particular portion is elevated, is a sign that there is myocardial infarction. And thirdly, we have the PP interval, which represents atrial reading. It's simple. From this point, the P to another new P. So you use it to measure the atrial reading. While RR is the portion between this R wave and the next R wave. We use it to measure the ventricular reading. So with this, we've come to the end of the ECG reading. I believe you now have a fair understanding of what ECG reading is all about. I would like to advise you to subscribe to this channel for more videos. Thank you for listening.